potential for 3D printing applications in construction in general. Not just a particular aspect of construction, but trying to put a systematic perspective on what goes on and what the future of this technology is. I know that the University of Wolverhampton is planning a 3D printing lab for concrete, and this is an activity that's growing in importance. I've just reviewed three super interesting proposals from one of the countries in Asia that are developing technologies for reinforced concrete that will be printed. Just imagine printing concrete and steel at the same time. How do you do that? It sounds mind-boggling at first, but there are ways to do that. So without further ado, I want to see if my remote works. Yes, it does. Just a brief overview of what I'm going to talk about. First, start with definitions. Who is who in that business? What's going on, and how can academics get involved? So at the end of the presentation, there will be some conclusions drawn as to how all of you as construction and allied professionals can contribute to this development. So what are those definitions? What's 3D printing in general? It's a process. It's a process like many production processes that we have seen with traditional technologies. But it's utilizing this additive manufacturing technology. So when you hear the term additive manufacturing and 3D printing and you're confused, it's the same thing. Manufacturing engineers talk about additive manufacturing. The jargon has it, and we talk about 3D printing. So the idea is to bypass a lot of the intermediate stages and go straight from a digital document directly into the production process, bypassing a lot of these other processes that were considered inefficient. So what about construction? Well, we're performing these activities at a different scale, much larger than in manufacturing. But in manufacturing, the technology has become mature to the point that it's changing the paradigm on how objects are being produced. And it's not just solid objects from metals and other substances, it's soft objects as well. Rubber can now be printed. Heart valves, medical objects, dentures for dental patients, bones for bone implants, you name it. Sky's the limit as to what you can do with 3D printing. So the big question has remained, what can be done in construction, and how can we fabricate not only individual structural and non-structural components, but buildings as a whole. Is it even possible? Is it feasible? Even if it's theoretically possible, would it make practical sense to construction contractors to use this technology? It's a question, a valid question still, but there are some interesting developments on the horizon that I want to talk about today. So first, let me talk about the types of 3D printing. It's not just one uniform technology. There are numerous competing technologies that sometimes use different materials, and with different materials come different technological approaches. So some of these technologies involve powdered metals, some involve resins, some involve even clay. And the material of choice for construction professionals is concrete. Most of the concrete material that has been found useful for construction applications is subject to trademarks, not trademarks, but secrecy in general. So we'll evade metal detectors at airports. Imagine what it could do to air travel. It could wreak havoc in our lives. So we're grappling with these challenges that didn't exist 5 years ago, and now all of a sudden we're faced with these technologies that we have to provide an adequate response to. The idea, of course, is placing layer after layer of the material in ensuring that there is sufficient structural connection between layers. So depending on the density of that material and the speed of the process, you can vary the quality, you can vary granularity of these materials. And you can produce objects that are just as good, or in some instances even better than those that are produced with injection molding, for example, or milling in steel mills. It didn't sound possible a couple of years ago, but right now it is possible. So why concrete? Well, concrete is the most sort of pervasive construction material just about anywhere in the world. I traveled to China a lot, and there was a report by the Gates Foundation in the US that indicated that the Chinese construction industry is so big now, it's more than twice as big as that in the United States. And China produced and used more cement in the last 3 years than the United States in the last 100 years. So if you look at what's happening even in residential construction outside of North America, because US and Canada are a bit of an exception, concrete is still the material for choice for residential structures. So concrete is here to stay, and 3D printing is probably not going to make a big difference in it. So the idea is how to best adapt and adopt this technology to produce concrete structures. And not very far from here, in fact quite close at the Loughborough University, there is a concrete printing lab that has been in existence for the last several years. And there are other centers in the UK that are becoming active in this research area as well. Is it working? So I just want to classify these 3D printing techniques by the types of objects that are being printed, by the materials and processes that are being used, and what kinds of technological solutions are being adopted as well. So as far as printed objects are concerned, we can talk about printing one piece, and we can print an entire component, perhaps a three-dimensional module that will be installed directly on the project. We can talk about producing, using 3D printing for production of support structures. Maybe a scaffold of some sort, and I'll show some examples of that. Also, we can produce molds for concrete and then for other materials as well. Molds that can take fantastic shapes. Sky's the limit as to what the architect can design with these kinds of molds that can be printed. And as far as materials and processes are concerned, we can use powders. Powders are extremely popular. And powders dressed or powder-based materials. Extrusion, similar to injection molding, is also quite popular. So it's cement and mortar that are being used for 3D printing, but also plastics and waxes of all sorts, and most recently also salt as a material for 3D printing. Various types of salts that can be used. And as far as technology is concerned, robotics is the king. You cannot have viable technological solutions in 3D printing and construction without mentioning robots. So robots in construction are not a real novelty. I have been involved with this technology for about 3 decades now. I remember we were promising in the 1990s that by the year 2000, every construction site will have a robot employed. Well, it didn't happen. Why? Is that because the technology is not good? No, the technology is fine. It's the fragmentation of the construction process. It's the lawyers telling designers to stay away because this is unproven technology. You can get into liability issues. And if you have an increased liability because of use of unproven technology, maybe your insurance will shoot up and then you will not be competitive. So all kinds of issues like that are being overcome. In the 1990s, we didn't have BIM. So fragmentation has been greatly reduced with the introduction of building information modeling, and now BIM is already a mature technology to the point that if you're trying to get an NSF grant in the US that mentions BIM, good luck. They won't fund it. Why? Because it's considered mature technology, so the industry should fund it. And the industry says, why should we even bother? The industry points to vendors. Autodesk, why don't they fund research on that? So it's a vicious circle, but at the same time, these breakthrough technologies are making a huge difference and are creating an opportunity for technology integration that didn't exist before. So what are those technological solutions that are prevalent right now in the market? Gantry-based systems. Just like gantry cranes that you see in various sports facilities, prefabrication plants, they are also very useful for 3D printing applications. There's a company in California that was started by a colleague of mine, Professor Keynote at USC, University of Southern California. He just took a leave of absence from his university job to launch this company, which is doing phenomenally well, considering all the constraints that are put on technological solutions in the US. We have traditional construction robotics that are either mobile or stationary that can become useful in the process as well. And we're also dealing with cable-suspended platforms. Italian design firms have pioneered this concept, and they're also making some interesting projects with it. So these are some drawings or sketches or images of what this may look like. The one piece, the Professor Keynote that I just mentioned, is right here. So this is an entire building module that can be produced by a gantry type printer, dispensing concrete and printing these walls. So a small residential building can be printed in roughly 48 hours or less. Some smaller structures can be printed in 24 hours. So imagine coming to the job site in the morning, by the end of the day, the basic structure is already printed, and the MEP crews come in and they install their services. That's entirely possible now. So even in prefabrication plants involving storage, involving transport, installation of these modules, you cannot achieve these kinds of schedules with conventional technologies. This picture actually comes from Blackboard. They produce these concrete components for a variety of structures as designed by architects. You can come up with a lot of fancy facades. If that would remind you of Antonio Gaudi, Barcelona, it's probably just like it, except that Gaudi couldn't possibly dream of 3D printing. In construction now, a lot of these flamboyant shapes are entirely possible. I lived for about 2 years in Abu Dhabi, in the UAE, and even during that time when I was there, which was 2010, 2011, nothing was being designed and built that would be straight up rectangular shapes. Everything had to be tilted and twisted a few times just to make an architectural statement. It was horrendously expensive to build a 3D concrete, reinforced concrete frame like that, and I was witnessing a couple of these projects in my own neighborhood where I lived. And the project managers would tell me that it costs anywhere from 8 to 10 times more for the support structures to be erected. And when you look at the cast-in-place concrete, about 75% of the total cost is formwork. How do you build formwork? Here, when you're printing, that problem goes away. So there are certain economies of scale that can be addressed with 3D printing that couldn't possibly be addressed with previous technologies. And I mentioned earlier support structures. So you can print a metal support structure over which you would apply concrete or any kind of foam material that would form the shape that is designed by the architect. So gantries are popular, are being used. This is a fantastic technology that is extrusion-based, and it's sort of similar to the welding process. You are forming a metal structure, possibly reinforcement, possibly an entire structural component, maybe part of a truss, extruding a metallic shape from powder-based material as we go. There's lots of videos on YouTube from a Dutch company that has already produced several footbridges in various locations in the Netherlands. I would encourage you to go and take a look at these videos. This is a cable suspended structure that can be used for a variety of purposes. Also produced quite quickly. Powder beds can be used to produce interesting architectural shapes. Clays are becoming increasingly popular. Why clays? They're relatively cheap. And they're ubiquitous. This is a natural material, so sustainable structures can be produced from clays. If properly treated with either plasticizers or other chemical additives, they can produce durable structures. So lots of interesting, let me skip on too many. The history of 3D printing and construction is relatively short. The first developments didn't start until mid-1990s. And I'm here to brag that the first paper ever produced on 3D printing applications in construction was published in Automation Construction in 1995 by a gentleman by the name of Joseph Peña, who at that time was an young, innocent assistant professor at Rensselaer Polytechnic Institute in upstate New York. This was quite a splash. He since then moved and became a consultant in Montreal, Canada, and is advising a number of architectural firms on what is possible with 3D printing technology. So he developed this sand and cement forming technique using what is now called a 3D printer. And then things followed up fairly quickly. Bero Kushniewicz at USC produced this method that he dubbed concrete or contour crafting. And that's also the name of the company that he started. It's contourcrafting.com if you want to look that up. And then what we're dealing with in the first decade of the 21st century is the first generation of these developments. So we can talk about not only contour crafting, but Enrico Dini, an architect from Italy, that formed a company called D-Shape that has already produced some interesting structures throughout Italy. And then previously mentioned concrete printing here in the UK at Loughborough University. So since then, there has been even more rapid development of these technologies. Now we are at the tail end of the second decade of this century, and we're dealing already with the second generation of this equipment. And what is that second generation? A lot of different applications that involve very exotic ideas, such as the use of 3D printers for extraterrestrial construction. Imagine European Space Agency in conjunction with a Korean Space Agency is now talking about a permanent human settlement on the surface of the moon. The ideas that architects are pursuing is a settlement for about 200 people. And it's not just for astronauts wearing their heavy spacesuits. They're talking about families, husbands and wives and children, staying there initially for 3-month stints on a rotational basis, coming and going every 3 months. But how do you imagine a daily life on the surface of the moon with families? No atmosphere, reduced gravity, about 1/6 of the terrestrial gravity, harmful cosmic radiation that can kill you, and no atmosphere, so no pressure, no water, everything has to be brought from Earth to sustain human life. But on the other hand, you cannot build anything with materials brought from Earth, because NASA has estimated that bringing 1 kilogram of payload from Earth to the moon costs about $3 million. 1 kilogram. So everything has to be built from native materials, from regolith, rock that's found on the surface of the moon, and that has to be the basis for the production of concrete. And concrete has to be produced with no water. No discernible water on the surface of the moon yet. That will be accessible for us to use in construction. So I have another slide and another deck of slides that shows a rapid progression of the development of 3D printing technologies in construction. And this decade has really advanced the processes to the point that they're becoming, slowly but surely, economically feasible. So it's the confluence of BIM, robotics, and now 3D printing technologies that is just about to start a revolution. I don't want to be a false prophet like some of us were in the 1990s, that by the year 2000 robots will be running around on every construction site. But the promise is really there, and it's becoming more and more realistic. So you can get these shapes that were entirely impossible with conventional methods because of conventional formwork systems. So the architecture of this century will not be like what we have seen before. Sky is the limit as to what kinds of shapes you can produce. So some of these look like futuristic sculptures, but they're real structures. Heesom is one of those companies that is doing that. I already mentioned Loughborough. Loughborough is producing very interesting shapes. Contractors throughout Europe are interested in new architectural designs that will be supported by these technologies. The big question remains as to how we can take advantage of conventional prefabrication plants and prefabrication technologies, how we can combine that with what 3D printing has to offer, and can conventional prefabrication yards become 3D printing yards for construction components. It's an open question. A lot of people are interested in seeing some feasible answers to it, and that's going to be a subject of active research. So, where are we now? The compressive strength of concrete that is achievable now is anywhere from 100 to 110 megapascals. It's likely to change. It's likely to change because of additives and because of fiber reinforcement that is being introduced, and I'm talking about glass fibers, composite fibers, and even steel fibers to some extent. There are techniques that are available. D-Shape by Enrico Dini is now already talking about the compressive strengths of 240 megapascals for the concrete mixes that they have patented. And it's on its way up. It's on its way up. There is a company, a startup company in the US, that now is talking about up to 400 megapascal type of concrete that would be available for printing. Hasn't happened yet, but I'm looking at the draft paper of one research lab that's collaborating with them, that they're interested in having it published after the patent is obtained. So a lot of interesting developments. There is this company in China by the name, actually there's a couple of these companies. This one company is producing villas and small houses as well. Also within 24 hours, they can produce 10 of these on any project site, and they have offices and project sites in southern China, mostly right now in Shenzhen, just north of Hong Kong, and the company is based in Shanghai. So they're active in this field. There's about half a dozen companies in China interested in pursuing this technology, mostly for building construction. But It's spreading very quickly. There's even a new company I just heard about last week in Chile, South America, that is interested in converting old prefabrication yards that were built in the 1970s into 3D printing for mass housing production for disadvantaged populations in remote areas. The government of India, together with Asian Development Bank, is sponsoring a project at National University of Singapore to print permanent toilets for rural areas in India. And that has been identified as a feasible technology to deliver those essentially public health facilities in rural areas of India. And mind you, India is the second largest population in the world, and therefore it's a very pressing problem. So that is already spreading around the world. So the company that I referred to is Winsum. You can look up lots of videos by that company also on YouTube that show feasible projects that they're pursuing. And it's the same process all over the world. Extrusion of concrete mixes that are patented designs that can achieve different compressive strengths, but with creative use of fiber reinforcement, even tensile strengths can be greatly increased. Conventional concrete tensile strength is about 10 times less than the compressive strength. With fiber reinforcements, not necessarily true. You can come up with very interesting numbers for that. So, where are we today? One of the issues that has been repeatedly identified as a bottleneck is, as you continue printing, how do you ensure that these cavities inside walls are left for services to be installed? There are a variety of ways to do that. You can insert various shapes to retain that space, or you can print in one go and simply create those voids as designed by the architect directly during the printing process. There are patented solutions to achieve both, but this is still an active area of research and development, so technology solutions will probably become quite creative in that regard as well. So, but now, as I mentioned, there are also companies and universities collaborating on the creation of technologies that will allow insertion of reinforcement steel, not necessarily just printing of reinforcement, but insertion of traditional reinforcement in concrete structures being printed on the go. There is even a very interesting branch of the toy industry. There's a Russian immigrant in Minnesota, in the US, who has created, he's a contractor, created a market for himself, built a concrete printer, and he is installing in his customers' backyards miniature replicas of medieval castles from Europe, usually for younger audiences, for children to play in. But imagine a scaled-down model of Schweinstein castle in Germany, or some of those that you can see scattered around southern France or also in the UK. He goes to these locations. He takes a 3D scan of that castle. He comes back to Minnesota. He reproduces it in concrete. That market didn't exist until the technology showed up. Are there other markets that didn't exist? Most likely. You can think of some inventive ideas that will take advantage of these technologies. So, other uses of the technology, inside these villas that are being printed, you can also print some of the permanent fixtures, maybe jacuzzis, maybe made of plastic, maybe other objects that normally would come pre-installed or would be installed by separate contractors. This villa was also produced using entirely 3D printed components and then brought into offsite and then brought onto the site for installation. So in that sense, it reminds us of traditional prefabrication methods, except that the production was done. Oh, this is one of those castles by Andrei Rudenko. That is now, there's maybe several dozen of these that are built just in the state of Minnesota. I don't know if he's doing business elsewhere in the U.S., but it's a market. It's a market. Dubai has been notorious for trying out new things, so they have contracted with Witsu to build office building modules that can be stacked up in different configurations, and they can be portable, they can be permanent as well. They haven't figured out exactly how to produce a high-rise building using 3D printing technologies, because building permits are increasingly more difficult to get as the size of the building grows because of structural rigidity and structural performance concerns. But in desert locations where human labor may be problematic, the use of 3D printers is quite viable. So this market is probably going to continue, and the structures can be produced relatively quickly. So this was an exhibit, a world exhibit, just last year in Dubai that showed off some of these printed modules that are now being produced for other projects throughout UAE as well. Okay, so there are also exhibition pavilions that are being built with the use of this technology. And a lot of these technologies are similar to one another, so we have some patent disputes right now between these companies. There are disagreements as to who was first to invent, and because of differences in patent laws in different countries. In some countries, it's who first invented, and in other countries, who first applied for a patent will be granted that patent. So because of different commercial interests, these disputes are likely to continue. Hopefully they will not slow down the process to the point that it hampers the use of the technology. So we'll see what happens. Sculptures and various objects that would be difficult to produce in conventional shapes are entirely possible with 3D printers. So for example, a column like that, or the entrance to the building, has been 3D printed, and it'll be more, and it provides sort of a better solution, a more interesting solution to a typical prefabricated shape that could be an eyesore. It would be kind of boring. If you look at the structure of the architectural statement, a column like this would make, for a lot of clients, it would become interesting. So the outside construction requires portable 3D printers. And unlike in manufacturing, in construction, for these printers to be feasible, they have to be large. So one of the bottlenecks was, how do you create a printer that could be quickly set up and quickly dismantled when the project is finished? That has been a challenge, but now there are some companies that have modularized the concept, where printers can be loaded on the back of a pickup truck, for example, or at least a flatbed truck, and quickly brought to the project site, set up, and then dismantled when the project is over. The pioneer of that concept is a Russian company by the name of Apiskor that is producing small residential structures. They're based outside of Moscow, but they're building these structures even beyond the polar circle in Siberia, where the temperatures are extremely low, minus 40 Celsius, and with concrete plasticizers, they're still able to produce these structures as long as it's not snowing or the wind is not blowing to the point that it would make the process impossible. The use of human labor is totally impossible in temperatures like that, whereas 3D printers, these new forms, these new concrete mix designs actually can support that. So you ask yourself, how is that possible if you're using water in concrete? How come it's not going to freeze? Well, as concrete settles, it's an exothermic reaction. So they have taken advantage of the fact that with the use of 3D printers, you can expand your markets into kinds of temperatures that you wouldn't think about before. So this is this company, Episcore. Some formatting problems with this slide, but this is their signature building. They can produce these shapes, circular shapes. There's also a nice video on YouTube that I would encourage you to look up. Just search for this company name and you can see what kinds of objects they're able to produce. So this is the modular printing system that they can unload and then load back on the back of a flatbed truck that carries this equipment directly to the project site and can make this arrangement within roughly 45 minutes. They can set up the equipment to work on the project. So this is a signature project for this architectural firm from the Netherlands, Das Architects. There was this renovation project. They knocked down an old structure located in Amsterdam, and they printed, according to the old documentation, an entire building sort of stuck in between two existing buildings that looks like it has never happened. The structure was there all the time. And the amount of labor that they saved is reported at least 40% of the contractor's estimate using 3D printers to produce this house. It's called the Canal House. So next time you're in Amsterdam, try to look it up and see for yourself what kind of quality is possible. One thing that they brag about is an eco-concrete fill. It's a specially made concrete material that uses, they say, less than 30% of the amount of cement that originally considered concrete material was supposed to use. So cement production is highly detrimental to the environmental performance. Cement production requires a lot of energy and generates a lot of pollution. So any solution that you can come up with, concrete material, that reduces the reliance on cement is actually very good. So when you look at the research and development that goes on in 3D printing technology, about 80% of the effort is spent on generation of new materials. Only 20% on equipment and other technologies that are related to the equipment used. It's really the material that is a critical component of this technology. So is it going to be concrete forever? Probably not. The biggest amount of resources that is being spent on 3D printing applications in construction is design of new composites that will be durable, that would deliver the structural performance that is needed. And that work is ongoing to the point that 3D printing or materials for 3D printing applications in construction has now its own biennial conference. The last conference was last year in Chicago. And a lot of people working in that field. So if any of you are interested in materials technologies, that's the field to get into because it's hot at this point in time. All right. So what else is going on with the technology? Well, there is a lot of interest in retrofit. How do you use 3D printing technology to refurbish existing buildings? Countries such as UK, most other countries in Europe have a lot of old building stock. This is the fastest growing market. It's not new construction, but it's really the retrofit of existing structures. That is likely to grow, and it has its own set of challenges. How do you produce these materials and these solutions that blend in with old structures, that have the look and feel of an older structure, yet it has been 3D printed and it has been installed efficiently. Building facades, so mixing old and new is a challenge for architects. It's a challenge for contractors as well. Those contractors who will specialize in the use of 3D printing technology for building retrofit are probably going to do very well in this century. And more and more countries are interested in that. My colleagues at Huazhong University of Science and Technology in Wuhan, in China, they're right now specializing in 3D printing for nothing else but architectural restoration. So taking those elaborate structural components like casetones, like different types of moldings in buildings that are extremely difficult to replicate in the field, that can be 3D scanned, taken to an off-site location, printed, brought back for installation. It saves a lot of money, a lot of time. And if the quality results can be produced, that's really the way to go. Another interesting development is biologically inspired cellular fabrication of building components. So the slogan that is used here is "Build like nature." What can we do? Well, lots of interesting developments. I don't know, how many of you are civil engineers by training here in the room? Almost everybody, or half of the people? Have you ever heard the fact, this is a real fact, that there was a civil engineer who won a Nobel Prize? There is no Nobel Prize in engineering at all. This guy won a Nobel Prize. Why? Well, he was actually a structural mechanicist. Bachelor's, master's, and PhD in civil engineering, in structural mechanics. He complained at one time that there was not enough research support for structural mechanics. So he hooked up with colleagues in the School of Medicine at his university. And they were interested in his structural computational background and said to him, hey, would you like to develop some structural behavior models and the mechanics of biological material in cells? And he said, why not? I can try. So he joined the team. Fast forward 2 decades, that led to the development of the field that is now called tissue engineering. You've probably heard of tissue engineering. And that in turn led to the development of technologies that are now patented, not fully approved by FDA in the US yet, to grow bones in amputees on structural scaffolds created from stem cells. So his team, not just him individually, but his team won the Nobel Prize for this technology, and he was one of the recipients. That's how a civil engineer got a Nobel Prize in medicine. So why am I telling you this? This technology has become an inspiration for what goes on right now in structural engineering and in fabrication of very durable, very strong, lightweight materials that can be 3D printed. So very refined three-dimensional trusses can be produced from very fine miniaturized structures that can be 3D printed, can be lightweight and extremely durable. Okay, durable to the point that if you use nano-additives, they can become practically indestructible. The jury is still out on the question as to whether having a totally indestructible structure is good for the environment, bad for the environment, or indifferent. Nobody knows for sure. One of the research areas that is being pursued now is nano-additives for construction materials. Nobody knows what are the environmental implications of that. So 3D printed structures will greatly benefit from nano-additives, but we don't know what the environmental impact is at this point in time. So I'm mentioning that because this is one of the open questions that is still being addressed. Many new developments are quite promising also from the standpoint of maintainability of structures. Imagine, we have nano coatings for glass right now, but they're very expensive. some of the translucent materials that can be 3D printed for windows will promise that you'll never have to clean a window because the grime and all the dust will actually stay away from this. So this is bad news for window cleaning contractors, but they can specialize in something else. They can retrain, regroup, readjust to the new markets, realities, the new realities that will be present in the field. So the build-up of these scaffolds over which you can apply sprayed materials using 3D printer has almost unlimited potential. So not just concrete, but foam materials, all sorts of plastics. Again, extrusion-based techniques can be used for that purpose as well. Let's see. We can also talk about new architectural statements, columns being built, beams and girders for large frame structures that are being produced from lightweight elements that are printed and then installed directly on the project sites. This is an architectural rendering of a new concept I think it's for the state of South Dakota in the US. This is supposed to be a new highway rest stop building on interstate highway system in that state. How would you like to visit a building like that? It looks somewhat cosmic, it looks futuristic, but these kinds of structures can be easily printed and delivered on project sites. You don't have to have conventional shapes to be able to do that. So this is the company from the Netherlands, MX3D. Please remember that name because I think they're going to be quite famous around the world for producing metal structures from not just steel powdered, but different metals for very durable structures. Right now, still at the small scale, but they're getting bigger and bigger. The economies of scale have not been determined yet. Right now, the technology is being tried on smaller projects, but stay tuned, and lots of videos on YouTube as well for this company. So take a look if you can. So this is just a picture of a bridge that is under construction, and robotic welding machinery is produced. They can use 1, 2, or 3 of these welders producing different components of that structure that can be assembled, or robots can actually work on, let's say, a bridge construction project from 2 different piers and complete the project in a relatively short amount of time. This is just an animation of one of those footbridges being produced, and they're extruding that shape as they go. So one of these bridges is already complete. So if you visit, I think it's near Wageningen in the Netherlands, where you can take a look at it and just walk through that bridge and see for yourself as to what the quality is. And in Amsterdam, there's another one under construction. So this is another company called Delta, and they have a robot that is suspended from a platform that is producing circular structure. They were collaborating at one time with the Media Lab at MIT to produce, MIT actually produced a foamed structure. Concrete material can be used for the production of silos and other circular buildings that can be erected quite efficiently with the use of this technology. What else is going on with respect to these tower-like structures? In fact, they can become modular. You can build these modules and you can stack them on top of one another. The only issue is structural performance. Can they withstand the dead weight and any live loads that you want to impose upon them? So with the use of new concrete technologies, especially fiber reinforced concrete, that's entirely possible. Free fab company can also achieve different structural shapes. They specialize in exotically looking roofs right now. Concrete roofs that are lightweight, that are sprayed over a lattice type structure. Roofs that can be installed relatively quickly, directly on the project sites that can be printed. A lot of roof replacement jobs are waiting for them. Warehouses, commercial structures of all sorts, they'll become very efficient in that business. So the fibers that they focus on is glass reinforcement fibers with this particular company. Okay, so what are the challenges and opportunities? I realize we have to wrap up quite quickly. As I mentioned, materials and processes. So construction materials, research and development will go on for as long as new solutions are necessary to facilitate the use of this technology. Robotics technology is also crucial to the success of 3D printers. And I mentioned BIM. BIM is sort of a glue that holds all these elements together. In order for us to efficiently deliver a structure in the field from a digital drawing, BIM is absolutely indispensable. So that market is still wide open as to who's going to do the integration, what are the legal challenges of that integration, organizational challenges, what are the implications of that integration for project management practices in construction. That's an active field of research and development. And last but not least, market life cycle, and then life cycle costing. What is going to be the cost performance of these structures? Nobody knows because there's no historical information. Simulation is not going to get you very far. You have to live long enough to see how these structures will perform over time. So there are some insights that rheology of materials can give you